Hi everyone, welcome to Naresh Technologies. This is Srinivas. In this session, we are going to discuss all the operations we can perform on single linked list. In the last session, we discussed clearly, so what is the node structure of a single linked list and how the memory we are allocating, right, to a particular node using a malloc function or malloc function in a C language, right. See. So, first here, what are the operations we can perform on single linked list? Single linked list operations. So, first one, append the element. So, nothing but insert or more clearly adding an element at the end of the list. Add at end is the first one. Second one, add at begin. Add at begin. Suppose after 5 elements insertion, right, in the beginning of the list, add first if you want to insert any element. So, that is also. Next one, add at after a particular node, actually nothing but in the middle, right, how to insert. Add at the end, add at the begin, in the middle, nothing but after a specified node, how to insert the elements. Next one, how to delete first node and how to delete a specified node. How to delete a specified node. Next, how to display elements. How to find length. Next, how to reverse the list, and next one, how to swap elements in the list. Swap 2 nodes or 2 elements in the list. Next, how to sort the elements in the list. How to sort the elements. So, all these operations we can perform on single linked list. We will see one by one. Okay, how can we perform all these operations, right. For example, so in a new technologies like in Java, right, in a collections framework, all these functions available directly, predefined implementations are there, so which are called a collection framework classes, right. But in C language, so we have to write the logic manually. I will explain all these things using a C language syntax, and if you are good at a core Java, complete logical programming, and then you can try exactly how to develop, how to implement the logic, right, manually instead of depending on predefined implemented classes, right. How can we write the logic, that you can try later, right. So, let me explain all these things, right. First one, how to append the element to list. Okay, see how to append elements to linked list, right. So, function. So, we are writing append, and list also we are writing list. How to declare a root variable means, so first, node type is a struct node in a single linked list. Here it is, int first one is a data, second one link type is a struct node type. Here it is a node structure contains 2 elements, nothing but 2 fields it will create. First one is a data and next one is a link field. So, first we are creating one variable, of course a global variable, just consider struct node star root, then root gets memory allocation at some location. Node gets memory allocation root. Now, so first we are checking, so what is the initial value, and of course global variables a default value null only. More clearly, if you want to assign, you can assign value is a null. root value initially null, that is nothing but, so what that is representing means, right, the linked list is not having elements yet. So now we are inserting the elements. How to insert? So first in the append we are creating one temporary variable. A temporary variable is also struct node star temp. It is also user defined data type variable only, that is nothing but node structure type variable only we are declaring, node structure type variable. And next one, we need to allocate the memory dynamically. Here it is malloc, and we are passing size of struct node we are passing. So we need to pass the size of the structure. So what malloc function will do means it will allocate the memory. See how it will allocate the memory. Here it is dynamically a block memory will be allocated. A block memory will be allocated at some location, and before that remember this temp variable also get memory allocation. Local variable, temp variable get memory allocation, and root variable is a global variable. Observe here it is a root already created. Now local variable is a temporary variable. So temp gets memory allocation. Next, using malloc function we are allocating the memory to structure, nothing but node type structure memory allocation here. So it allocates the block. The address is a 2046. Address is 2046, that we are collecting into local variable temp variable first, and of course here typecasting compulsory, struct node star type conversion. So after typecasting we are collecting into temp. So here it is 2046 we are collecting into temp. So it start pointing to this node. So as of now node is ready, node memory allocation is ready. And next what we have to do, we have to read the information. How to read? We are asking printf enter node data. So what data you want to store inside the node, that we are collecting. Enter node data. Sir, how to scan, sir? %d, because integer data. Now observe very clearly temp. So node is having two fields. So what is the data field and what is the link field, that you cannot decide, but address 2046, next one 2048 consider. For scanf function, to read the information we have to provide the base address, very important. See, temp to data address. Once again very clearly, whenever a pointer is pointing to the structure we need to use arrow operator to read the elements, nothing but to process the elements. So here it is a temporary variable is a pointer variable pointing to structure. So we need to provide this address to scanf function. So temp to data location address. So here temp to data address, this is reading information. Just consider if they give 10, the 10 will be collected into this location 10. Next here I want to place null value I want to place. So here null value we are collecting into temp to link field, directly we are storing the value null. Temp to link field value is a null. Now node is ready completely, only node memory allocation is ready, and what are the values, what is the information we need to place inside the node is ready. Now we need to check where we have to connect this node, right, either at the starting position or at the end of the available linked list. But as of now we are creating the first node in the linked list. We are creating the first node in the linked list. So, we have to check with the root element. For example, if root element is not pointing to any other element, the newly created element should be the root element. See, here we are checking the condition. If root element is equals to null, so what it is representing? The root is not pointing to any node. That means, so whatever the node you have created newly, that is comes under newly created element, and that should be the first element. So, in this situation, we are assigning the temp value to root. We are assigning the temp value to root. So, what is the temp value? Observe here clearly. Temp value is a 2046, and the root value, temp value we are storing into root. Root is already null. Now that we are replacing with a temp. So, it start pointing to the first node. Sir, then what about a temporary variable? It's a local variable. You declared locally inside append function. So, whenever append function execution has been completed, then automatically that will be deleted. Right? Local variables will be deleted along with the frames destruction. Sir, what is a frame destruction? We know that methods and blocks executes in the stack memory in any programming language. Once the frame is going to destroy, along with all the local variables will be deleted. So, this is only first case. Sir, what about a remaining cases? What about a remaining cases? Else block logic. In the else block, remaining logic we have to write. So, remaining logic I will explain clearly. Okay, see. For example, if you are inserting the first element, right, how to insert the element directly temp variable we are assigning to root is happy. Next, suppose some of the elements are already present, so then else block will execute. How it executes? See. For example, already some elements are present in the list. This is the first element, this is a second element, third element, fourth element. 4 elements are there. 40, it's null. How to store all these things I will explain. So, here it is, root element is pointing to the first location, first node, and some of the nodes already connected. Now, we are inserting one more element. Already node is ready, right? For example, using malloc function, first we are creating one temporary variable. Temporary variable gets memory allocation, temporary variable. Next, using malloc function, we are allocating the memory to node. Suppose this is the node. For example, at some location is a 2012. First, the address we are collecting into temp variable. This is temporary connection. Temp is pointing to this one. Next, we are reading the elements using printf and scanf. Already we discussed just now. Alright, how to read the elements. Right, we are reading the element to temp to data address. Suppose value is of 50, and next temp to link will be null. Reading is over, but now final part is the connection part. How to connect element at the end of the list. Okay, now if block will be terminated if root equals to null. If root equals to null, what we have written? So, temp value will be assigned to root, or else now here it is, we have to write the logic now. In the previous case, suppose if you are creating the first node in the linked list, by that time root will be null only, but now root is pointing to some other node, is pointing to some location. So, what is that location? 1024 is the location, right? It is pointing to 1024 location. So, that root not equals to null if condition has failed. So, that we have to connect. Sir, how to connect? First, you have to travel from first location to last location. First location to last location, because newly connected element you have to insert at the end. You have to insert at the end. Sir, how can we connect? Observe here. We are declaring one more temporary variable. Here it is struct node pointer, for example P. P gets memory allocation at some location. It is also pointer type only. Initially into P we are storing the value root value. Here it is, root value is a 1024. So 1024 will be stored. So temporarily it is pointing to this one. Why temporarily? Because it's a local variable, temporary variable. Whenever a function execution has been completed, along with the temporary variable, P variable memory also will be deleted, as it was a temporary variable, nothing but a local variable. Now we need to send the control from first location to last location. How to send, sir? Very simple. With the help of one while loop. While P2 link not equals to null. P2 link not equals to null. Just store the P2 link value into P. Why? Because we need to send the control from first location to last location. So how can you decide that you means what? The control sent to the last location means last location link field is a null field, because no other connection, no other node connection from the last node. So that you should keep it in mind, because based on null pointer only we should travel from first location to last location. First P2 link we have to check. What is that? P value is a 1024. 1024 to link. This is data field and this is the link field. Suppose if this link field is a null field means what? It is the last node, because no other connection. But now it is not the null field. It is 2092. So nothing but some other node has already connected. That you should understand. So what is the value? 2092. So not equals to null. Condition true. Come inside. That P2 link value will be stored into P. So what is that P2 link value? P2 link value is a 2092. That will be stored into P. Then it stop pointing to first node. That P is start pointing to second node. Next while loop. As long as the condition is a true, it will repeat. So what is the second node? Again P2 link not equals to null. 2092 to link 7058 not equals to null. So that 7058 P2 link value will be stored into P. It stop pointing to the second node and it is pointing to the third node. 7058 to link not equals to null. Yes, of course 9058. So that value will be stored. It stop pointing and it is start pointing to the last node. Now 9052 to link. 9052 to link is a null. Null value not equals to null value, condition false. Then while loop will be terminated. At the end condition false, because P, the temporary variable, is already pointing to the last location where we have to connect the newly created node. So what is that newly created node? Is a 2012, is already in a temporary variable. So connect now. Temp variable, newly created node, right? Here it is, we are assigning to P2, P is pointing to the last node, P2 link location. So temp value 2012 will be stored here, then it pointing to this one. The 2012 will be stored into P2 link. This is connection. Okay, first node connection is very easy, but if you want to connect remaining nodes, first we have to travel from first location to the last location. Sir, how to travel from first location to last location? So for that, so we need to declare one local variable, another temporary variable, by which we can travel. So, once we reach the last location, so then we have to connect the newly created node at the end of the list. So, this is the insertion part, how to insert an element, nothing but how to append an element in a linked list. Some more features of a linked list, and so remaining operations on linked list will continue in the next session. For more videos, please subscribe to Naresh IT channel. Thank you.